you to understand. And these slides are available on the D2L equipment, what type of equipment you need to perform the injection molding process. This is the extruder. Extrusion and injection molding. Uh, we have a die through which the material molten material is passed, and it requires the shape of the die, which is known as extrusion. Like you studied in the earlier stages, if I go back to lecture 3, maybe lecture 4, I still know, lecture 5, that drawing and extrusion. Yeah, in this case, this is the extrusion process, that the material is pushed through the die. And similarly, material here, this is not metal, this is all plastic. We have to melt the plastic, and then that molten metal, molten pellets, they are passed through the die with a push force of this screw. The screw keeps on rotating, and it keeps on moving the plastic in the forward direction as it rotates through the motor, and the motor spins, and the material starts moving slowly towards the die, and then it pushes through the die, and once it pushes through the die, it acquires the shape of the die. You see, this is the extruder. These are small noodles like structure coming out of the die, and the extruder is this is the extruder. You see the hopper. If I show you the hopper, the the material is fed through the hopper, through these pipelines, and then it has air. What happened? Let's stop working. So this is the hopper, okay? And the material comes, this is the motor for air is injected inside, and the material goes inside, and then it goes inside there is a screw, the motor is rotating with some mechanism here, the belt, and the is a helical screw, okay, and it passes through the die process. And there is another process, injection molding. So we have a die, and this is on the other side. So the screw, the material is being fed through from right to left inside the die. This is the die, maybe. Oh, this is a whole die. So if it is enclosed inside the die, then it's a injection molding process. If it is not enclosed but comes out through the die, it's the extrusion process. Do you understand the difference? In extrusion, we don't have a closed die. The material is fed through the die, and it keeps on moving out. But in the mold, it 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 fills up the mold cavity. It's like casting. You see the difference between injection molding and extrusion process. These are all injection molding machines at the um, Kraus Mafia at Ford. You see, this is not an extrusion, this is injection molding, and the screw keeps on rotating and pushes the material through the die. And this is my die, the cavity. If you take closely look, this yellow color is the cavity. Once the cavity, it looks like this shape, okay? It looks like this shape, and these are the This may be the extra. So you have to cut from here in order to, this is my uh, the part which I need. This is the picture of the die, steel die, two parts, and the material, the plastic material, it can manufacture a lot of parts. Okay, this is steel die, and the plastic is not going to ruin the steel. Okay, it can create, like in sand molding, we have to, it's expandable. Sand mold was expandable. We have to break the sand mold in order to take the casting outside. But here, we don't need to break the die. We just open this die and knock out the plastic part, and we have to do some trimming of some of the extra material. Like I mentioned, the trimming for this portion, but actual part is needed. This is another uh, steel mold, which is the cavity of a replica of the part. If it is a replica, means the cavity and where the plastic is hosted, injected inside. Modular molds, so you can have multiple type of molds. uh, this is all engineering. You should know how to design engineering molds. This is the mold and schematic. This is the knockout pins that once the part is complete, so this can move back and forth to just uh, remove the plastic material, finalize die material. Okay. So this is the final shape. We do have runner, gate, sprue system, and the cavities. Cavity is this one. This is my cavity. So we can trim off this part from here. We don't need this. We need our part. This is our actual part. You see my point? So this, yeah. So what happens in the process, in the injection molding process, that it keeps on rotating. Okay, the material keeps on rotating and the screw keeps on moving and the material keeps on moving into close to the die, and then once it reaches the die, and suddenly it has a greater push into the die. So these are the step-by-step processes. How do we acquire the injection molding? So you will read it. I want to jump ahead to the formula because you can read them at home, how the process happens step by step. We have some heaters and some friction between the motion of the pallets. The pallets, due to friction, they heat up and then they melt. We have to have a melted plastic near the die, and then the screw comes forward to inject, and the final shape is acquired in the die. So these are the pallets. Air inject. Air is also the part of the injection process of melting up. So I will explain the nomenclature in a bit, uh, but these are the processes. The screw keeps on moving forward. The material injection pressure, typically 15,000 psi, which is sufficient to melt the plastic pellets, which are in the hopper. Processing time is about 35 minutes, or 35, sorry, 35%, I would say. Okay, this is in second, time is in second. You see the maximum pressure happens right over here at 5 minutes. At 5 minutes maximum pressure, once the part is injected, the pressure starts reducing and the temperature is also reduces, and the part is ejected over here after maybe half an hour. Temperature history. Temperature is very high at the injection step at 5 minutes, and then after it is injected, temperature starts decreasing. We have to solidify the plastic. The gate is the area where the cavity is available. So you can move the plastic into the gate. Injection. So let me show you over here. Okay, we have to go over the analysis here. Okay, this is the picture, the nomenclature of the parts in the extrusion mechanism, and this same picture have been reproduced for the students in the colors so that you should know where is the screw. Let me show you, there is a screw and there is a barrel. Barrel is uh, is where the this is the part, is the outside surface, and these are the heaters. The red colors are the heaters. We have heaters along with the motion or the pushing force. uh, we do have heaters, and this is the polymer. You see, polymer is squeezed between the barrel inner surface and outer surface of the screw. You see my point? Outer surface of the screw and the inner surface of the barrel, they squeeze the plastic pallets. Okay, the last thing which you can do is draw this picture, and that is we will start the velocity of the barrel, everything on Thursday. Can you show me the picture in your notebook? Then you can, after this, you can leave. Let me close the recording here.